Hi, my name is Johnny Lee, and among the many concerns around coronavirus, one of the growing concerns is around the shortage of available ventilators that might be needed in the case of an acute respiratory attack or distress. Now, there's a lot of efforts around the world trying to accelerate the production of FDA-approved ventilators, and those are definitely the best path, if possible, if those can be ramped up in production. There's also a growing interest around what might be possible with really low-cost designs that aren't nearly as good as a professional ventilator, but might be usable or even helpful in an emergency. To help accelerate this effort, I wanted to share a design that I've been working on that might be simple and easy to build in the case that official ventilators aren't available. I'm interested in getting feedback from medical professionals or engineers on how this might be more useful medically or easier to build. Now, I'll start off to say I'm not a medical professional, and this is not a medically certified device. So if you have professional care available to you, you should definitely seek that out over anything you might see in a YouTube video. This design is composed of four major components. We have the DC power supply. This is an optional 12-volt battery backup. This is a breathing tube. This is a face mask from a CPAP, and I'll explain what a CPAP is in just a moment. And this is the blower that causes pressure to go into your lungs. This blower is actually from the inside of an old CPAP that I had, and CPAPs are devices for people who have sleep apnea. And CPAP stands for continuous positive airway pressure. And what it does is it blows air into your lungs so you don't accidentally stop breathing while you're asleep. I have a few of these old ones because I'm really interested in what was inside of them. And it turns out that the blower is simply a standard brushless DC motor, which can be driven by a standard electronic speed controller found in quadcopters or even RC cars. And it can be driven by an Arduino. And the nice thing about having this control is that now I can modify the software to change the speed of the blower to meet whatever profile I want. And this is what enables the CPAP motor to function as a partially capable simplified ventilator. Now, to put it together is pretty simple. I just take one end of the breathing tube into the face mask, the other end of the breathing tube into the blower that has this tapered end, which has been 3D printed on it to make the blower fit. And then I take the DC jack and turn on the battery and plug it in. You'll hear the motor go through an initialization sequence, and it starts off in a low pressure level CPAP mode. So it's blowing continuously right now with the air pressure. And this will push air into your lungs. And I have this toggle switch in here, which you push once to change the speed. And there's 5 levels of speed. And then it goes back to the normal level. If you double click it, it now goes into a BiPAP, where there's 2 different levels that the motor is oscillating back and forth between. It's currently programmed at 16 cycles per minute, which is kind of an average breathing rate. And this, if you put the mask on, will actually force air into your lungs at this level. And we can change this speed with software. If you single click again, it will actually cycle up and down between faster speeds, up to a maximum speed that is approximately equal to 20 centimeters of water of pressure. Again, that pressure is programmable, so this profile and this speed can be completely changed with a simple Arduino IDE. I'll turn this off. If you don't happen to have this mask because you don't have a CPAP, you can use this sort of 3D printed mouthpiece. This is kind of modeled after an intubation adapter or mouth guard, but we're not intubating people, but this will actually go into the tube, and you can strap this onto the head with just simple elastic straps. And as a result, this is a pretty minimal solution that might be useful in an emergency. I'd like to quickly show you how the different headgear works, just to give you some ideas and also to show you how it goes together. The first one is the CPAP mask that I have. This is from a company called ResMed, and this is the AirFit F20. The nice thing about this mask is that it covers both the mouth and the nose. So as the air pressure comes in, it covers the entire airway, forcing the air into your lungs. You just put it on front, bring this over the back, and these magnetic clips hold on the side, like this. This one is an alternative to a face mask if you don't happen to have one, but it's a 3D printed adapter that's kind of modeled after an intubation tube, an intubation mouthguard. This slips onto the tube just like this, and it has elastic straps just like a standard face mask. The bad thing about this is that it doesn't cover the nose, and so there's potential for leakage unless you use something like tape to cover it up. I've also done some basic testing of pressure that's possible with this blower, and this shows the blower oscillating between about 10 centimeters of water and 20 centimeters of water at a rate of 16 cycles per minute. This is a picture of the basic test fixture for measuring the output pressure achieved by the blower. The U-shaped tube is filled with liquid, and the blower is blowing into the top of one end of the U and measuring the distance that the liquid on the other end of the tube is being pushed up. This gives me a conversion of air pressure into centimeters of water, which is what's commonly used in respiratory devices. Now, in terms of overall cost, the system can be pretty cheap. I used a fancy battery pack here, but if you just replace this with a high enough power 12 volt 5 amp power supply, that can be gotten for about $20. This is tubing from a CPAP, but could be replaced with standard tubing from a hardware store for the cost of about $5. This face mask is pretty fancy and is for a CPAP, so it costs about $75 new. But this 3D printed mouthguard with elastic straps is just a few dollars worth of parts. And the blower plus the Arduino and the electronic speed controller is probably available in volume for about $30 or used if you can find it on eBay. I will put links to the GitHub, which has the files for the 3D printed models, as well as much more documentation about how I modified this blower, as well as the code for the Arduino. As I mentioned in the beginning of this video, the main reason I'm sharing this isn't to say that this is perfect and it's done, but really to accelerate ideas and get feedback and learn from you about how to make this better and how to make this more effective. And hopefully it becomes useful in a time when proper ventilators might become extremely rare. So if you're a medical professional or you're an engineer that has suggestions, please contact me. Also check out the GitHub link for much more detail and technical information about how this was built and the measurements that I took. Hopefully this is useful. Thanks for watching, and hopefully everyone stays healthy. Thanks.